Hello everybody, today we're going to learn about arrays of objects and arrays of pointers to objects and how the memory is allocated at compile time and runtime. So let's begin. To explain the concepts, we're going to use a rectangle class which has two fields, length and width. It got constructors, setters, getters, and a print info function that prints length and width. And visually, we can represent these rectangle object using this box. It has two fields, length and width, which represent the length and width value of the rectangle object. So in the main function, the first type of array will be declared statically and is made up of rectangle objects. So both rectangle array as well as the rectangle objects that is made of, they are declared statically. Now let's see how the memory is allocated for the rectangle array as well as the rectangle objects at compile time and runtime. So this rectangle array is made up of rectangle objects. So at compile time, this can be represented at three rectangle objects. So the memory is allocated for the size of three rectangle objects. So R1, 0, R1, 1, and R1, 2. These are the three indices. They would represent the three rectangle objects that will be later stored into R1. And then the code for these rectangles is executed. So here we have rectangle 1 with length and width value 1, 1, length and width value of 2, 2 for rectangle 2, and the third rectangle has length and width value of 3 each. So at runtime, the exact memory is allocated in the RAM when the program is executed. So they both look same at compile time and runtime. Now if we want to print information about rectangles, we can access the first rectangle using this index R1, 0, and then we can call the print info function on it using the dot operator because this rectangle was declared statically. So we can just use the dot operator to access any of these setter, getters, and print info function. Now the second type of array will be declared dynamically, but is still made of rectangle objects. So if we see here, this is the configuration, rectangle pointer R2. So remember, R2 is not the rectangle array, it's a pointer to rectangle array. Equal to new rectangle 3. So it says that the array is going to be of size 3 and it's made up of rectangle themselves. So they are declared statically. Now this is a pointer to rectangle. So visually we can represent it as this. This is an address. So R2 is not the rectangle, but it's a pointer to rectangle. So in the beginning, it'll store some garbage value and it's pointing to some random location. And that's all that happens at compile time. Now at runtime, this configuration is copied over to RAM. So R2 is still contains a garbage value. A new rectangle array of size 3 is created and it doesn't have any rectangle objects in them just yet. Let's assume this rectangle array was created at location 100. And then the three individual rectangle objects are created with values 1, 1, 2, 2, 3, 3 for the length and width fields. And then because of this equal to operator and we created this array object dynamically, this address is copied over to the pointer variable R2 like this. And now we have a pointer that can point to the memory location where the rectangle array is located. So we can go there and access the three rectangle objects. Now if we want to access the individual elements, we can use the same statement as before. It'll be R2 0.printinfo because the first element we can access using R2 0 and it'll print 1, 1, 2, 2, 3, 3 based on which rectangle we are accessing in the array. Now the third type of array we can create is an array that is statically allocated, but the objects are not the rectangles, but the pointers to rectangles. So visually it'll look like this. It's an array of rectangle pointers. So it's an array of three addresses. So in the beginning, these three array elements, they will have just the garbage value. They'll be pointing to some random location. At runtime, they'll still be there. So we can still access R30, R31, R32, but they are pointing at some garbage location. And then these three individual rectangle objects are created dynamically. Remember, we are using the new keyword for three of them. So that means they are declared dynamically. And whenever there is a dynamic allocation, we take their address and then we store it at memory location. So that's why the first array will be stored here and the second one will be stored here and the location for the third rectangle will be stored here. And that means now this rectangle pointer array which can point to individual rectangle objects. So R30 will have this memory location 110 where it can go and find the first rectangle, the same with the second and the third. Now if we want to print information about individual arrays, we need to use the arrow operator. Remember, R30 is just an address. Get to the actual rectangle object, we need to use this arrow operator. So R30 arrow print info and it will print 1, 1 for the first rectangle. So in the last case, we're going to declare an array dynamically, which is an array of pointers to rectangle. So if you look at the syntax, the first part is rectangle star star. So there are two asterisks. The first one of them represents that this is going to be an array of pointers to rectangles, and the second asterisk, it represents that R4 is declared dynamically. So that's why we are using the new keyword here. So rectangle star star R4 equal to new rectangle star of size 3. So this star here represents this is an array of pointers to rectangles. So if you compare it with the second case here, we were declaring R2 dynamically as we are doing it here because this was an array of rectangles themselves. So we didn't put a star here. But here in this case, R4 is an array of pointers to rectangles. So that's why we are putting the star here to represent that this is going to be an array of pointers to rectangles. Now at compile time, only the left side of the statement would execute. So that means this part. And because R4 is declared dynamically, it will be just an address which contains the garbage value. Runtime will be copied over onto RAM. So this memory will be allocated in RAM exactly how it was at compile time. Then this statement would execute, which is going to create an array of pointers to rectangles. So again, there are no addresses in there, so it'll still be an array of addresses that contain garbage values. And let's assume this array was created at location 200, which will be later copied on to R4 pointer variable. In the next step, this statement would execute, where it's going to create 3 new rectangles dynamically like this. And because they are created dynamically, we need their addresses, which will be stored into this address array. So these 3 addresses will be copied over onto this array. And because the values are copied over, that means now each individual addresses will point to respective rectangle objects. And lastly, this equal to operator would execute, and the new rectangle array that was created, its starting address will be stored into R4 like this. And that means R4 now has the address of the memory location where the array is stored, and we can go there and access individual rectangle objects. Now, if we have to print individual rectangle objects, we can use the same statement as before, and we're going to use the arrow operator because each of these rectangles, they are declared dynamically. So we need to use the arrow operator to call any functions like print info. So when we call this function, it's going to print 1, 1 because we are accessing the first element of the array. So those are the 4 ways to declare an array. The first case was when we declared the array statically, and this was an array of statically allocated rectangle objects. The second was when the array was created dynamically, but the rectangle objects were still statically allocated rectangle objects. The third way was when we created an array statically, but individual array elements were created dynamically. And in the fourth case, the array as well as the individual rectangle objects, they were created dynamically. Thanks for watching.